Yes.
Right. Can I just get you to start off by introducing yourself? Just tell me your name and just tell me what you did.
Well, I'm Hugh Harris, and for many years, from 1963 to 1998, I worked in public affairs for NASA. First at NASA's Lewis Research Center in Cleveland, which is now called the Glenn Research Center. And then in 1975, I transferred permanently to the Kennedy Space Center in Florida, where I spent the balance of my career.
Can you just tell me how you actually became involved in that in the first place? How did you actually come to join NASA?
Well, I was always very interested in... I was always very interested in science, and actually could not decide whether to study science as a career goal or to study writing, because I was also very interested in the media and writing. And because I was given a scholarship to a more academic university, I became a writer. And I worked in the news media during the very earliest beginning of the space program. And then for a short time worked on writing a magazine for Standard Oil of Ohio, which is now British Petroleum, and then went from there to NASA at the Lewis Research Center.
Okay. What did your work actually involve? What was your brief?
Well, primarily it was to keep the public knowledgeable about what was going on in the program. And through, in the earlier case, through working with the media and in writing stories and articles and doing film clips and getting people on television shows and things to heighten the awareness of what the country was doing. As I spent longer time in public affairs, then eventually when I became a director, I had both the media outreach, also the educational outreach, the VIP sort of outreach, and also the large visitor center that we have at the Kennedy Space Center, which I helped enlarge during the time that I was responsible for it.
So that's quite a broad range, broad brushstroke job, isn't it, really?
Well, it's a far-ranging job. There's never enough resources to do everything you'd like to do. But I think it's terribly important. What happens in science does not become real to people until you tell them about it in a number of ways. And storytellers have really been the fabric or the mechanism by which science and civilization has been advanced throughout history, beginning back when people sat around fires, or maybe before they sat around fires, and talked about what they were experiencing in the world. So I think that the role of people in the news media, in of course education, and in all areas of the arts is absolutely essential to the advancement of science.
You were with that job from the 60s all the way through to the 90s.
Yes.
Talk to me about how the job changed, because I can imagine that became much more difficult as time went by.
Well, I don't believe it became more difficult. I never noticed a lack of interest on the part of ordinary people. Now, the politics change as things happen in the world, and politicians come and go, but and also the funding for programs change according to politics and according to what else is happening. If you're at war or something like that, of course, the priorities change in the country. But as far as regular people are concerned, I've never known really a lack of interest on their part. Now, during the Apollo program, when we were getting ready to go to the moon and finally went, there was sort of a heightened awareness, I think. But part of that was media driven. The media could not get enough stories about what was going on. And what is unfortunate in today's world is that people are forgetting what the effect has been on the lifestyle of people around the world and on the way in which they are able to take care of themselves, and medicine has advanced, and of course the technology of transportation, television, all of that sort of thing, communication, tremendously changed.
So, I mean, right at the beginning, you're dealing with, the first batch of astronauts. What are your recollections about the way that they handled the media and the way they were taught to handle the media?
Well, I think the early astronauts were basically test pilots, and a fair percentage from the Navy and the Air Force, etc. The test pilots are a garrulous group, and certainly they're quite willing to go talk to most anybody, and perhaps a little boastful. So I think they were good ambassadors, and actually they as probably more than anybody recognized the importance of the teamwork that was going on. In order to put one person on the moon, well, we did two at a time, you really needed about 250,000 other people who were doing their jobs. So they were, in some ways, they were fairly humble and knew the importance of the other people that supported them, and understood that they were really a sort of an ambassador from we Earthlings to going up into another heavenly body. So there's probably a dichotomy there in that there was a little bit of being torn between their usual selves and understanding what their place in history was.
Do you have any specific memories of particular astronauts, about their, the way that they approached I mean, that was, like you say, that was part of the job, about the way that individuals approach the job? Well,
first of all, it's important to realize they're all very human. And the idolization that happened, of course, is not always the easiest to handle for them. But I think more and more, as we went further and further into the program, that became apparent to them. And it was not, since there's been, I think, 473 people have now flown in space, it's not quite as special as it was when only one or two had flown in space. But yes, each of them was unique in what they did. Certainly Alan Shepard, who was the first American to go into space, was somebody who really, I think, saw the big picture. He was a very social person who enjoyed large gatherings of people. And one of the problems we had as public affairs people who went out with him to speaking engagements and that sort of thing was keeping track of them, because he would be invited to go here or there. And he was very willing to do that. And but at the same time, after he retired as an astronaut, he made a tremendous contribution to education in the country both through his personal speaking engagements, but also through the Astronaut Scholarship Fund, which has provided funding for engineering and science students now for many years. And I can't remember what number they're up to, but it's many millions of dollars that have been raised. And he was a great fundraiser going out, and one of his specialties was playing golf with people. And they paid many thousands of dollars to do that to the scholarship fund. And this was not, for him personally. Also, he and a number of the other astronauts proved to be very astute business people. And after their NASA career was done, they went out and worked at very large companies and accomplished a great many things. Alan Shepard, in particular, was a very bright in the real estate world and made quite a lot of money in buying and developing property, among other things. John Glenn, for instance, became the president of RC Cola and served in that capacity for a number of years, and then became a United States Senator, and was an excellent senator. Some people who go into politics, go there sort of as stars, and they're there really not to accomplish a whole lot. But John Glenn, I think, had a very great insight into the problems in the everyday world, both nationally and internationally, and proved to be a very fine senator for many years. Each one of the astronauts is unique, and for instance, going back to the early ones, now I've forgotten his name.
Which mission was he?
Let's see. He was one of the Mercury astronauts.
Grissom?
No, he wasn't. Grissom was in much later than the Mercury program, and oh dear, no, he was much later too. It was Shepard, Glenn.
Scott Carpenter?
Scott Carpenter is one. Thank you. The Scott Carpenter was very interested in underwater exploration as well as in rocketry and space exploration, and he made a major contribution to living under the ocean, which also in turn made another contribution to living in space as well. Because in some ways the things are not dissimilar in that you're detached from the real world, and you have to learn to use the resources at hand and to maintain a livable atmosphere in a non-friendly place.
That's some of the people who were comfortable with the sort of media spotlight on them. Are there any that spring? I mean, Neil Armstrong always gave me the impression he wasn't very happy with the whole media thing.
Well, I don't think he was unhappy with the media as much as.
Could you do me a favour? Could you say Neil Armstrong? Just start
Yes.
it off by saying I don't think
Yeah.
Neil Armstrong is.
Neil Armstrong was a lot like Charles Lindbergh, in that he felt that the focus should not be on him so much as on the program. And he also felt that he should not use his celebrity in a way for personal gain. So he was very reluctant to have interviews. He went back, and he's a very fine professor of engineering and mathematics and things, and taught for many years at the University of Cincinnati, I think mostly graduate students, but others as well. And he now has cooperated in writing a book that has come out, which is really quite good. But he's quite different from Buzz Aldrin, for instance. Now, Buzz Aldrin, who was the second person to set foot on the moon, sort of always felt he ought to be the first one. And for whatever reason, while they were there, he never found time to take pictures of Neil Armstrong on the moon. However, Armstrong took many pictures of Buzz Aldrin. And whether Buzz Aldrin, must be said that he was very busy with the things they had to do, because you may remember that the first moon landing was relatively short, and they didn't stay there very long, and they didn't have much time to accomplish what they had to do. As a matter of fact, some of the things they'd taken up, the tools, didn't work properly. For instance, taking core samples of the surface of the moon proved to be much, much harder than it is here on Earth. And actually, the surface of the moon is very granular. It's sort of like very, very, very fine sand. However, when you push a core instrument into it, it won't go in very far, and they broke it off. So it was difficult, but I think that you have a quite a difference in personalities sometimes, and also in the teamwork that they represent.
Did you actually commentate on launches?
Yes, I did probably 100 or 200 unmanned launches, or of just satellites and spacecraft and that sort of thing. And then I did probably 30 or 40 of the space shuttle launches, but I didn't do any of the Apollo launches. That's, being the commentator is a very small part of the job. It's important. It's part of how do you keep people informed about what's going on, and what's going to happen next, and if something goes wrong, what does that all mean? And it's also a great opportunity to tell people what the particular project is all about. Why are we going to do that particular thing, and what kind of science is it going to yield, and that sort of thing. So it's very important to the program, and also to just keeping people informed about what's going on. But it's a very, very small part of the overall public affairs program.
But presumably there's quite a lot of preparation for that, is there?
Well, yes, especially when you start with a new vehicle. In my case, I was well aware of what had been done in Mercury, Gemini, Apollo, and had been down to the Cape and to Houston to help with the public affairs for it. So I knew the programs very well. But when we got a new vehicle, the space shuttle, then the preparation for that first launch, took many weeks, sitting in on all of the technical meetings and understanding exactly what happened in the vehicle when you lit the engines or got ready to light the engines, and what to expect as it went up through the various stages into orbit. So it was very exciting, but it took several months of a fairly intense preparation. And then once you have the first one, you certainly become more comfortable with the second and the third and the fourth and the fifth. And the script that I developed, which told me when I was looking at it at the console, here's the things that are supposed to happen and what time, then I could transfer that to the other people in the office so that it wasn't quite as big a problem for them to prepare. And later, as we got later into the program, I felt it was always important to have more than one person who was prepared to do the commentary. And people don't realize, usually they remember the last seconds or maybe the last minute of what happens, but actually the commentator talks for several hours in telling people what's going on, in a large extent the news media who are there, and then also the people who are at the various viewing sites.
You weren't commentating when Challenger?
Yes, I was.
You were. Yeah.
And
could you talk us through that? Just to talk to me a bit about, you know, what actually happened there.
Well,
not specifically, you know, the disaster, you know, the disaster itself, but basically, you know, what happened while you were commentating.
Well,
how you reacted to that.
I think in the case of Challenger, which of course was a great disaster for the program, I don't know that anybody who was in the firing room, and the firing room is really the Launch Control Center, had any idea of the discussions that had gone on, for instance, the night before and before that, about what the problems of cold weather might bring. And that was the coldest time what the weather had ever been for the launch of a space shuttle. And the only thing that was raised during the countdown was fear that icicles which had formed on the gantry might fall and hit the thermal protection system, the tiles that insulate the shuttle orbiter as it lifted off. And Rockwell, at the time, which was the prime contractor for the shuttle orbiter, did some fast analysis and came back and said that that wouldn't happen, that there was no problem from the ice that had formed. And every element of the launch team, which includes all the major contractors and each of the NASA people who oversee various parts, such as the propulsion and the electrical and the hydraulics and all that, all had to say, you know, yes, they were ready to go, or they you know, saw no reason to halt the launch. Now, when the launch occurred, you know, it didn't take too long before we got a burn through of one of the solid motors. And what basically had happened was that the cold had really soaked into the solid motors and had affected the seals, so that the tremendously hot flame from inside the motor had been able to leak out and to actually cut through the case, and that caused one of the solid motors to come loose and to be sort of peeled away from the vehicle. And that, of course, released, well, it actually first tipped over and broke through the tip of the external tank that carries the liquid hydrogen and liquid oxygen, and released that, which then, of course, you got combustion. People talk about an explosion, but an explosion never occurred. It's just that when you have a huge volume of hydrogen that's ignited, you know, it's very, very fast, and it seems like an explosion. But that was, what was surprising to me was that so many people then suddenly decided that they were opposed to the launch and said, well, you know, I told people that, you know, there was a problem. And there had been meetings the night before even at the Marshall Space Flight Center in which it, you know, people expressed the opinion that it was not wise to launch under these conditions, and others expressed the opinion that that was not a problem. But in the long run, people had basically agreed that, yes, we're going to go ahead. There's, a couple million parts to a space shuttle, and it's possible for, a number of them to fail with no problem, and it's possible for one to fail and cause a catastrophic problem. So it's a very difficult call for the managers and for the launch director, who he hears from everybody sitting in the firing room, they are ready to go. He really doesn't have a choice. He can say, well, I feel funny about it, I'm going to stop. Feeling funny about something like that and stopping it is at a cost of many millions of dollars. So it's a very difficult thing, and a lot of people tried to second guess, what happened there.
Can you talk me through that launch from your personal perspective? Because I mean, the thing that most of us remember is, after the explosion, ignition, that phrase, obviously a major malfunction.
Yes, that wasn't me, by the way.
Okay.
Once the vehicle clears the tower, and you probably heard me say, we've cleared the tower, that's the signal for the commentator at the Johnson Space Center in Houston to start talking. And he's the one who said, obviously a major malfunction. Nobody, of course, instantly knew what had happened. As a matter of fact, it really took a couple of days to figure that out as to what exactly, well, not exactly what went wrong, but just sort of the sequence of things. And I can tell you that, when that happened, it was very, very quiet in the firing room with everybody trying to figure out what just went wrong and what can we do about it. And there's all sorts of plans that are in place. Every bit of a shuttle countdown, and if there's a contingency, are actually plotted out in very thick books. And there is about 3 of them for each launch that are about this thick. And every step that they take starting at the time that the countdown is started is really a checklist. A countdown is a checklist of each step that has to be taken. And if something goes wrong, then you quickly turn to a different section, and this tells you what you have to do to make it safe at the pad or wherever it is, and to continue on. In the case of Challenger, there was a disconnect from the public affairs standpoint from the contingency plans that had been written. Public affairs, for instance, had a contingency plan, and it said, here's what happens if there is an accident. However, that had not been integrated with the operational people's contingency plans, which said, for instance, that you immediately impound all of the video from every camera anywhere. And so we had a big problem about all of the video that we had on tape was taken away to be placed in safekeeping for the investigations that would follow. So we had nothing to give to the news media who weren't there. And by the time we'd gotten the Challenger, which was the 25th launch, I think, of the shuttle, most of the media were not there, and only one was broadcasting live. And so everybody was used to, anytime you want something, you call us up and come and get it, and it's no problem. So that was one of the problems that we had.
Yeah, I mean, I was going to ask you, I mean, whether or not you rehearse in your own mind how you're going to react to something like that. If say,
Yes,
explosion
and as a
had.
matter of fact, there had been, previous to this, there had been some rehearsals, which were called simulations, and there was one planned for the month after the Challenger accident, which involved all of senior management. And had that occurred before the launch, it would have resulted in much better communication with the general public. Now, it didn't change anything as far as the investigation was concerned and how you recover. It just made NASA look like it was running around like chickens with their heads cut off. And so that was unfortunate, but as I say, it didn't change anything as far as the actual finding of what the problems were and the fixing of it. The other thing that occurred, that there were several things that came together, as frequently happen when there is a catastrophe. One of them was that the administrator of NASA, who is the top person in the agency, had just left, and there was a temporary person in the spot who had not been with the agency for very long, who was appointed by the White House to come over and take over. The person who was the head of public affairs at NASA headquarters had recently just taken that job too. So all of the practice and the plans that we had had before they came into the office, they really were not as familiar with as other people were. And then we had to say, well, here's what the plan says we're going to do. And they'd say, well, I'm not sure that's what we ought to do. Well, at the time of an accident or something like that happening is not the time to change your plans. So that was unfortunate timing as far as the accident was concerned from an administrative standpoint.
It's never a good time for something like that to happen, really, is there?
No, there's never a good time, but there's sometimes worse times than others. And as I say, it wouldn't have changed anything as far as what had happened or how we recovered from it, although it did change the character of how that happened. For instance, because the new administrator who was acting, not really in place, was not even at the center for the launch, and was unsure of what he should personally have been doing. The President of the United States decided that the only way to really do it properly was to have an investigation board that was formed at his level, not at the NASA level. So then we had the problem of that board wanted to be told something before the press or other people were told. So you added another layer of bureaucracy to the system, and that's always unfortunate. Layers of bureaucracy do not help sort out technical problems at all.
Trouble is, it always seems as though the first reaction is to put another layer of bureaucracy.
That's exactly right.
Are there any other things that you think we need to talk about? Any particulars?
Well, I don't think, as far as rocketry is concerned and public affairs, I would say that one of the things that's terribly important for any country, and certainly the UK is a prime example of where it's important, is that young people who are growing up need to understand what role advanced technology and advanced science exploration plays in what their lives will be like, and the economic strength of the country. This is also a problem in the United States and elsewhere, certainly, but I think in Great Britain that it's equally, or in some cases, more significant. The only thing that that really countries like ours have to sell to the rest of the world is advanced technology, because we don't have enough resources that we can be completely self-sustaining. Actually, no country can be completely self-sustaining in today's world. So what is the what do you do in order to keep the standard of living high and to raise it for all of the citizens in your country? And the way to do that really is in education and in the sciences and technology area. One of the things that's happening in the world, and hopefully Britain and the United States will end up being in the forefront of that sort of thing, is really at the molecular and the atomic levels, and in sort of nanotechnology. And this not only offers tremendous advantages in what you're able to accomplish, but also in the lowering the need for energy coming from hydrocarbons and that sort of thing. So there's, what has happened in the space program. At last count, for instance, there was 30,000 improvements in the medical field alone that came out of the space program. There's really hundreds of thousands of improvements in various areas of human life that have come out of that. And in by allowing or mandating that the people or the scientists or technologists in any particular country are going to stay abreast of what's going on and to make contributions to it, is what assures that their residents and their citizens are going to be able to take advantage of that. And of course, that's one of the big problems in third world countries, is that they operate with a great many handicaps in, first of all, not having the institutions that can do that, but not having the educational forums for the young people that are being raised. You get handfuls of people who become doctors and nurses and possibly engineers and scientists. But what needs to happen is that needs to be greatly increased. Certainly the Chinese and the Indians and other countries are really forging ahead. Of course, stem cell research is another area that there's going to be tremendous things happen in the future. And the countries that learn how to, take the next steps are the ones whose citizens will benefit the most.
Absolutely. That's excellent.
Oh,
thanks very much indeed.
Oh, you're welcome.
Right.